For the first problem, you have to determine whether a function is even, odd, or neither. Here are a couple quick tips. To find out if a function is even, that means it's symmetric to the y-axis, so you have to plug in a negative x value. So what we'll do here, we're going to do -6 times the quantity of negative x cubed minus 4 negative x. And then we just simplify it from there. Negative x cubed will still be a negative x. So that will be, that'll be a negative times a negative, so it'll be positive 6x cubed. And then same with this one, you have -4 times a negative x, so that'll actually turn into a positive 4x. So since this expression and this expression are not equivalent, or this equation, sorry, those equations aren't equivalent, it's not even. So we're going to write not even. And for the odd test, it's the exact opposite. If it's odd, it'll be symmetric to the x-axis, so you plug in a negative y value. So for this one, it's a little easier since we have y equals -6x cubed minus 4x. You would just put in negative y. And it obviously is not symmetric to it at all, so it's not odd. So since it's not even or not odd, it's obviously neither. The next type of problem is to determine whether f of x is continuous at a given point. So all you have to do is plug in the given number that they have for you. So c would just be that given number, such as c is all real numbers. So for this one, we have f of x is equal to 7x cubed plus 3x squared minus 6. And they want to know if the graph is continuous at f of -8. So all you have to do is go in and plug it in. So you'd have 7 times -8 cubed plus 3 times 8 squared minus 6, and you go ahead and simplify that, and in your final answer, if f of -8 equals some real number, then it's a continuous function. So do the problem, see if it equals a real number. If yes, then it's continuous. The biggest set of problems that you have is the set that asks you its graph's end behavior, the intervals, and the symmetry. It also asks whether they are continuous or not. So we'll go ahead and we'll define continuous in here too. So we're going to start with end behavior. When they're asking about end behavior, they're really asking what a graph is doing as x approaches infinity. So I'm just going to sketch a really quick graph right here. Say this is my x-axis, and I'll just do a quick almost sine curve, and it's going to continue in both directions. So I'm going to look at this portion of my graph as x is approaching positive infinity. That means as the graph continues this way, it looks like my graph is still increasing. It's increasing as x approaches infinity. So you could write that. I would just write it like this. As x approaches infinity, f of x increases. and your book may have you write it look like something different. Now, if we're going to negative infinity, it looks like our graph is decreasing as we're approaching this way. So the graph is decreasing because it's really as it's going in that direction, approaching. So we would write kind of the opposite. As x approaches negative infinity, f of x, which is just our function, decreases. And that's going to be different for every situation you see. But really, if you can use the graphing calculator to see the graph, you just look at what the graph is doing as it goes to positive infinity and what the graph is doing as it approaches negative infinity. And it'll always be, as long as it's specified, x is approaching. So you're going to look this direction for positive infinity and this direction for negative infinity. Now your intervals that it's asking for, I'll go back up to this graph as an example. It might say between what interval is the graph increasing. So you look, and I would say from, let's see, x equals, this might be 2 or something, to 4, our graph is increasing, or our graph is decreasing from something to something, or from something to something. It would be decreasing. Continuity. If a graph is continuous, it's going to look like this one up here. Now, if a graph has discontinuity, it can look like any of these. These are your graphs that have, they might have open circles where a number can't equal something, where x can't be this number for it to be a function. It might look like something like this if it's discontinuous. You might have a line going this way, and then you might have an open circle, and you might have a horizontal line going across. That's a discontinuous graph. A continuous graph is a graph that keeps going, and there are no breaks in it, there are no open circles, no nothing. X is constant, the same the whole way through. Okay, and finally I'm going to review the symmetry test because I think it's really important. And I would take these notes and keep them. The symmetry test you have to see if it's symmetric around the y-axis, x-axis, or origin. So y-axis, plug in a negative x value. X-axis, plug in a negative y value. And the origin, you plug in both a negative x and a y. And if the answer is the same or equivalent, then it's symmetric to the condition. So let's say you plug something in for a negative x, and your answer is the same equation that you started with, then it's symmetric. If it's not, then it's not symmetric to the y-axis. We'll do one as an example here. We have 2x y equals 8. And we'll do x-axis symmetry. We'll do y-axis symmetry test, and then we'll do the origin test. So for the x-axis, we plug in a negative x value, so that would or negative y value, I'm sorry. It's always the opposite of what you see, so it'll be 2x times negative y equals 8, and a negative y times this will just be a negative 2xy equals 8. This does not match this, so it's not symmetric to the x-axis. For the y-axis, you plug in a negative x value. So we would have 2 times negative x, y equals 8. Kind of the same thing that happened with the x-axis. It'll still be negative 2xy equals 8, which does not match your original equation. So that's another non-symmetric answer. And then finally the origin. You plug in both a negative x and a negative y value. So we would have 2 times negative x times negative y. And here it's a little interesting because a negative times a negative is a positive, so you would actually end up with 2xy equals 8. So this one is exactly the same or equivalent to your original equation. So your graph for this one is symmetric to the origin. So for that answer, you would write symmetric to the origin, but not the y or the x-axis.